Hello my dear students, how are you all? I hope you all are doing very well and spending this precious time through learning our channel Nirja Education. Don't forget to subscribe our channel. So today we are going to start second chapter of your class 10th maths and which is polynomials. About polynomials in one variable and about that degrees you have already learnt in your class 9th. So in this chapter we are going to discover more about polynomials. But before that, let's have small recap about it. Here I am going to start with algebraic expression. Now what do we mean by algebraic expression? As I have written on the board, a combination of constants, variables and operators is called algebraic expression. And I hope you all are knowing these terms constants, variables and operators. Constants, that means any numbers like 2, under root 3, 4 which value is never going to be changed. Variables you can take as x, y, u, t, v, etc. And operators as you all are knowing plus, minus, division and subtraction. So let's form some of the algebraic expression through its definition. Here first I am going to write x plus 7. As you can see, I have used variable, constant and operator. Another I am going to write 1 upon under root x minus 7. Another I am going to write under root x multiplied by 3. As per the definition of algebraic expression, we can call this all expression as algebraic expression. Now, how to find out these algebraic expressions are polynomial or not? Let's see. Here I have written 3 algebraic expression and from that only this algebraic expression is polynomial. Why? Because the definition of polynomial stated that an algebraic expression of which exponent of variable is whole number is called polynomial. So here we need to see the exponent of variable. As you can see in the term x plus 7, the exponent of variable x is 1 and 1 is whole number. So we can call this term as polynomial. And here as you can see the exponent of x is 1 upon 2 and which is not whole number. So we cannot tell this term as polynomial. Same here also the exponent of x is 1 by 2. So here also this term we cannot call as polynomial. Now let's see another some examples of polynomial. I can write as x square plus 2. The exponent of variable is whole number. So this is called polynomial. In other I can write x cube plus 2x square plus 3. So my dear student, to find out the particular term is polynomial or not, we need to consider the exponent of variable. And if exponent of variable is whole number, then you can say that term as polynomial. Now let us find out about degrees of polynomial. So now let's move towards the degree of a polynomial. How to find the degree of particular polynomial? So the highest power of x in p of x is called the degree of the polynomial p of x. That means if we are taking any polynomial in x variable, so we can call that polynomial as p of x and the highest power of x in that p of x will be called our degree of the polynomial. Here I have listed some of the example. Let's see how to find degree of polynomial by examples. First I have written p of x is equal to x plus 2. As you can see, here we have taken the polynomial in variable x. Now we need to see the highest power of x and here we are having only one variable that is x and highest power of x is 1. So we can call the degree of this polynomial is 1. Now let's move towards the second example. Here I have taken p of x is equal to 2x square plus 6x plus 7. As you can see, this is also we have taken the polynomial in variable x. So here we are having two places x, right? One is this, another one is this. But we need to consider the highest power and the highest power of x is 2 in this whole polynomial. So we can tell the degree of this polynomial as 2. Third, I have written P of u is equal to 10u cube plus 2u. As you can see here, we have taken the polynomial in variable u. So, we need to consider the highest power of variable u. Whatever variable is there in the polynomial, you need to see the highest power of variable. Highest power of variable is 3. So, we can tell the degree of this polynomial as 3. So, my dear students, now you have clear idea about how to find the degree of polynomial. Now, here as you can see, the degree of this polynomial is 1, and the polynomial which all are having degree as 1, we can say that polynomial as linear polynomials. The polynomials which are having degree as 2, that polynomials are known as quadratic polynomial. And if any polynomial is having degree as 3, we can say that polynomial as cubic polynomial. So, my dear students, here we have discovered 3 kinds of polynomial. First one is linear polynomial, quadratic polynomial and cubic polynomial. These polynomials are very simple. Those polynomials who all are having highest power of variable, that means degree as 1, that is known as linear polynomials. Those polynomials who all are having degree as 2, that we can call as quadratic polynomial, and those which all are having degree as 3, that we can call as cubic polynomial. Now, let us see how we can write this all kind of polynomial in general form. So, now we are going to see about general form of a polynomial. Just now we have seen 3 kinds of polynomial: linear, quadratic and cubic. So, let us see the general form of this all kind of polynomial, so that it is easy for us to identify which kind of polynomial is given. First one is linear polynomial, and as I say, the polynomials which all are having degree as 1, that all are known as linear polynomials, and in general form we can write like ax plus b, where a and b are real numbers and a not equal to 0. That means the coefficient of variable should not equal to 0. Next one is quadratic polynomials. The polynomials which all are having degree as 2, they are known as quadratic polynomial, and generally we can write like ax square plus bx plus c, where a, b and c are real numbers and a not equal to 0. The variable which is having highest term, the coefficient of that should not equal to 0. Third one is cubic polynomials. The polynomials which are having degree as 3, they all are known as cubic polynomial, and generally we can write like ax cube plus bx square plus cx plus d, where a, b, c, d all are real numbers and a not equal to 0. So, these all are general form of linear, quadratic and cubic polynomial. So, now I hope you all are able to identify which kind of polynomial is given by their general forms. Now, we are moving towards very important part of your chapter, and which is zeros of a polynomials. Why this part is so important? Because this part is having connectivity with others part of this chapter. So, if you are having clear idea about this part, then it will be going to useful us in later parts. So, now let us start zeros of a polynomials. First of all, I am going to consider one polynomial. Here I am writing p of x is equal to x minus 7. And as you can see, this is linear polynomial because the highest power of variable is 1. So, we are going to start first with linear polynomials. Here, now what I am going to do is, I am going to take the different values of x, then I am going to put that value on this polynomial, then we will be getting another values, right. Let us do so. First, I am taking the value of x as 0. That means, we are going to put the value of x as 0 in this polynomial. Instead of x, we need to write 0. So, p of 0 is equal to 0 minus 7, and 0 minus 7 is equal to minus 7. Another value I am going to take is x is equal to 2. Again let's put 2 as value of x in this polynomial. 2 minus 7 is equal to minus 5. Now I am going to take x is equal to 5. Let's put 5 on this in place of x. 5 minus 7 is equal to minus 2. Now I am going to put the value of x as 7. P of 7 is equal to 7 minus 7 is equal to 0. Now if you have noticed, whenever I have taken the value of x as 7, I got the answer as 0. So we can call 7 as zeros of polynomial. Why? Because whenever I am going to put this value on this equation, we are getting answer. We are getting our p of x as 0. So my dear student, this is very easy. Zeros of polynomial. Suppose I am going to take any real number as k, and k is said to be zeros of polynomial if p of k is equal to 0. That means if I am going to put such value of x in polynomial, for that I am getting the p of x, answer of this polynomial, as 0, then that value we can consider as zeros of a polynomial. Now next question arises in our mind is that how to find the zeros of different kind of polynomials like linear, quadratic and cubic. So about quadratic and cubic polynomial, we will discover that in later part of this chapter. So now let's see how to find zero of a linear polynomial. But before going here, I would like you to revise the definition of zeros of a polynomial. If k is a real number, it is said to be the zero of polynomial p of x if p of k is equal to 0. That means if k is any real number, and by putting that number in our polynomial p of x, if it turns into 0, then we can say that k is 0 of particular polynomial. Now let's see how to find 0 of a linear polynomial. For that we are going to consider one linear polynomial. I am going to write p of x is equal to ax plus b, as we have studied general form of linear polynomial. Now let's say k is a 0 of polynomial. Let's say k as a 0 of polynomial, and if k is 0 of polynomial, then it must be p of k is equal to 0. Now I am going to write p of k. That means we are going to put k in place of x. P of k is equal to ak plus b. But as we have supposed k as a zeros of polynomial, p of k must is equal to 0. So instead of p of k, we can write 0 over here. 0 is equal to ak plus b. And if I am going to find the value of k, it will be minus b upon a. So our k is, we have supposed as 0 of polynomial. So here we got equation. By using it, we can find zeros of any linear polynomial where k is equal to minus b upon a. As you can see, b is a constant term in the polynomial. So instead of b, we can write constant term. And this a is coefficient of x over here. So instead of a, we can also write coefficient of variable. It is coefficient of variable. So as you can see, coefficient of variable in the polynomial, it is related to its zeros. Now we have seen how to find the zeros of linear polynomial, but what about quadratic and cubic polynomial? Are the zeros of quadratic polynomial is related with its coefficient, and how to find that? That we are going to discover in later part of this videos. Now let's see one example how to find zero of linear polynomial. So just now we have derived the equation to find the zeros of linear polynomial. Now let's apply that equation and let us see if we are able to find the zeros of linear equation or not by examples. Here I have taken two polynomial. First one is p of x is equal to x plus 5. Now I am going to compare this polynomial with the general form of linear polynomial, which is p of x is equal to ax plus b. Let's find our a and b from this polynomial. Our b is 5, which is constant term, and a is a coefficient of variable. As you can see, the coefficient of variable is nothing, so we can take as 1. A is equal to 1. Now as per the equation, k is equal to minus b upon a, we are able to find zeros of this polynomial minus b. That means minus 5 upon 1. So this is the zero of this polynomial. To verify, you can put this value of k in place of x and let's see this polynomial, it turns into 0 or not. Verify it by yourself. Now next we are going to see is p of y is equal to minus 9y minus 6. So here also we are going to compare this polynomial with the standard form, which is p of x. If we are going to write p of y, it will be ay plus b. Now let's find our a and b from this. A is a coefficient of variable and coefficient of variable is minus 9 over here, and b is minus 6. So as per our equation, k is equal to minus b by a minus b, that means minus 6 upon minus 9. Minus 6 will be 6 upon minus 9. So by putting this value of k into this equation, you all are able to verify that this value is 0 of this polynomial is or not. Now we are going to conclude our session for today over here. I hope you all are having clear idea about polynomials, their degrees, how to write their general forms and how to find zeros of polynomial. We'll see you in next class.